All right, so let's look at something called Bernoulli's equation. All right, let's look at Bernoulli's equation. Now, in our previous class, when we talked about the first order non-homogeneous differential equation, we said the form of a first order non-homogeneous ordinary differential equation is given by dy dx, this plus u of x y it's equal to v of x. So we said this was a form of a first order non-homogeneous ordinary differential equation. What we said at this point, just take your integrating factor and we proceeded. Now, when it comes to Bernoulli's equation, the simple change, it is basically the same concept, but just a simple change. Now, the simple change now for Bernoulli's equation is that I would now have y raised to a certain power n. All right. The introduction of this y raised to power n to v of x is what transformed the equation to what is called a Bernoulli's equation. So this is the form of a Bernoulli's equation. All right. We know that dy dx can still be written as y prime. So this is the same as y prime. I'm saying that dy dx is still the same thing as y prime. So in essence, this can still be written as y prime plus u of x y is equal to v of x. Then y is to power what there? And I have this. So this is what is called a Bernoulli's equation. So that's about the form. Let's see how we can solve this. Method of solution. How do we solve this? Method of solution. All right, let's look at how to solve Bernoulli's equation. I'll give you these as steps. All right, so I had to form these steps to make it easier for you. So what I'm giving to you now basically are my own notes. All right, I have to study it, then form a step-by-step approach such that if I can remember the steps there, I can solve any problem that relates to Bernoulli's equation. Step number 1, please. Given a Bernoulli's equation in the form dy dx plus u of x y equal to v of x multiplied by y to the power n. So step 1, if I'm given this, given this, please, given this, step one is to divide through, all right, step 1, divide by y to the power n. That's the first task. Divide the equation through by this one here, by y to the power n. To make this easy for ourselves, let me give you a pattern that I want us to work with to make this easy for ourselves. So look up, please. Look up. Watch this. If I divide through by, let's say I have a, I want to divide a by y to the power n. This is simply a divided by y to the power n. If I want to write this in index form, first things first, shift this man out of this. It becomes a times 1 all over y to the power n. That's the first thing there. Now express this one here in index form. That will be equal to a times y. This becomes what there? Minus n. So here's what I'm trying to say. If I say divide a by y to the power n, it is still the same thing as saying multiply a by y to the power what there? Minus n. It's the same concept. So if I say divide through by y to the power n, it's the same concept as multiply through by y to the power minus n. Let's work with this. So multiply this one here by y to the power minus n. What do you have there? It becomes y to the power minus n times this times dy dx plus this one here, y to the power minus n multiplying, let's have this as u of x y, this equal to this one here, y to the power minus n multiplying v of x y to the power n. All right, I want to cancel this one first. So that's the concept. Now, if I multiply, what do I have here? This gives you y to the power minus n dy dx plus these two obviously can work out because what do you have there? The same base. So we'll add or subtract par. I would have this u of x into this is y times y. That becomes y. When two same bases are multiplying, what do you do there? You add their pars. The par here is minus n. The par here is plus 1. So that's simply minus n plus 1, which is the same thing as what there? 1 minus n. In essence, here becomes 1 minus n. Please take notes, take notes, take notes, take notes. So I have this as 1 minus. So this 2 gives you 1 minus n is equal to, this gives you v of x. If these two, what's it called? If they multiply, that gives you n minus n. Same base. So add the parts, becomes plus n minus n. That becomes y into n minus n. Let's save ourselves the stress. N minus 1 gives you what there? 0. This gives you 0. From the zeroth law of indices, anything to the power 0 gives you what there? 1. So this gives you 1, literally. I have 1. This times 1 gives you what there? Itself. That means this man is gone. Step 1 is done. Divide 2 by this. So I have this. That's the first task. Step 2, multiply 2 by 1 minus n. Please take notes. Multiply 2 by 1 minus n. Just follow my step. This would help you solve it better. Multiply 2, that's the second step. Multiply 2 by 1 over 1 minus n. So whatever thing you have here, you get 1 minus that value, then multiply through this equation by it. So multiply everything through by 1 minus n. What do you have there? 1 minus n times this one. That gives you what there? 1 minus n times this one here. Y to power minus n dy dx. Okay. Next up, this one here, plus 1 minus n multiplies all of this here, which is simply u of x y to power 1 minus n is equal to 1 minus n multiplies this. That becomes 1 minus n into v of x. So I'm done with this. Next up, step 2, multiply 2 by 1 minus n. So you have this. Call this your second equation. Let's call this first equation. Let's call this equation 1. Let's call this equation 2, please. This should be at the right hand side, but there's no space here. Let me write it here. Step 3. Step 3. Step 3. Let z, step 3, let z be equal to y to power 1 minus n. Step 3, let z be equal to y to power 1 minus n. Let's have this. You make this assumption, we need it in substitution and solution. Let z be equal to y to power 1 minus n. Now from here, please, what would be dz dy? Differentiate these two. Differentiate this. What do you have? How do you differentiate this one here? For this, would you use the par method or the general method of differentiation? What's the concept there? Multiply by the par, subtract 1. What's my par here? 1 minus n. So it becomes multiply by the par, 1 minus n, subtract 1 from the par, it becomes y to power 1 minus n, then minus 1. So you have this. Right. Multiply by the power, subtract 1. Simplify this. What do I have here? This is equal to, this becomes 1 minus n, y to power. Of course, this is 1 minus 1. This will cancel this. I'm left with minus n. So I'm having minus n. Please note this. So dz dy is 1 minus n multiplying y to power minus n. I have this. Okay, let's do a bit of manipulation, a bit of mathematical manipulation. What's the manipulation here? We know that we can get dz all over dx using the concept of chain rule by saying dz dx is equal to dz dy times dy dx. Yes, this works true. This is chain rule manipulation, such that this can cancel this obviously to give you dz dx. So it's correct. Now let's do that substitution. This is equal to, what's dz dy? What's the value there? Sit here. That becomes 1 minus n into y minus n. This multiplied by what there? Dy dx. This value is this times dy dx. So times dy dx. All right, so you have this. We now have a value for dz dx as well as z. So you have this. This is step number 4. Step 4, I will substitute dz dx and z into which of the equations? Into equation 2. Yeah, that's step 4. Let's do that substitution and see what we get. Let us do that substitution and see what we get. Let's put dz dx and z into 2. So look up, please. Here is 2. What's your observation? See something. Do you observe that? Look up, please. 2 says 1 minus n, y to power minus n, which is this one here, and then dx. In essence, all of this is what you have here. From here to here is what you have from here to here, and that value is equal to what there? dz dx. So if I substitute, all of this forms dz dx. So equation 2 becomes dz dx. Okay. Next up, plus 1 minus n. Okay. Plus 1 minus n into u of x. Okay. Into u of x. Right. Into y to power 1 minus n. Now recall that we said let z be equal to y to power 1 minus n. This one here becomes z. So u of x z. All right. So u of x z is equal to what I have here. 1 minus n. Okay. It's equal to 1 minus n into v of x. So I have this. All right, so you can take this down. Let's call this equation 3. Let's call this 3. Let's call this equation 3. Let's call this equation 3. Let's call this equation 3. Number 5, equation 3 is now a linear non-homogeneous first ordinary differential equation ODE in Z and can be solved using the integrating factor approach. All right, so that's it. We'll take some examples and see how we can deal with this, right? Take some few examples and then see how we can deal with this. So basically, this is your method of solution. Get this right and we're good to go. As usual, I'll give examples and we'll see how we can deal with this. Um, Example or sample problem. Let's give some sample problems. Sample problems. Number one, you have dy dx plus 2 over xy. It's equal to y cubed all over x cubed. Y cubed all over x squared. First example. Dy dx plus 2 over xy equal to this. So number two. Number two, you have dy dx plus y equals to 3 exponential x y cubed. Number three, you have x squared y minus x cubed dy dx, it's equal to y to the power 4 cos x. So you have this. Let me see if I have any other one left. Xy cubed number 4, dy dx plus 2 over xy, it's equal to x squared y cubed. Okay, see how some other questions here. This is for number 5. Number 5, we have dy dx, it's equal to minus 3 x squared y plus 4 x squared y squared. This is 5 minus 3x squared y plus 4x squared y squared. A final example, question number 6, you have x squared y to the power 4 minus 1 dx plus x cubed y cubed dy equal to 0. All right, so you have these. Okay. All right, let's look at these questions. Let's solve these questions, and if you can solve this one here, then we'd assume that we've now known Bernoulli's equation, right? So let us proceed. Okay, guys, so look up. Let's start with the first example. We have this dy dx plus 2 over xy, it's equal to y cubed all over x squared. This stuff here is a Bernoulli's equation for just one reason. What reason? Because you have a y term here. So if there was no y term here, I would have had something that looks like this. 1. Yeah, I'd have had this. at this point becomes a first order non-homogeneous ordinary differential equation. Now use integrating factor. But now there's a problem. What's the problem here? I have y to power 3. So it becomes a Bernoulli's equation. Please note the form of each of this. In your exam, you will not be told for the Bernoulli's equation below. You will not be told. You just say solve. So you have to look at it and know, is this Bernoulli? Is it first order non-homogeneous? Is it first order homogeneous? Am I using integrating factor? You have to know these things on your own. How do you solve this? The first step for this, as we said, is to look at the y term here, right? The y term here is basically y to power what there? 3. That's the y term here. So the question is this, what's n here? This was, if you look at the form was this. Okay, first, before we get the form, let me shift out this y cube. This will become dy dx plus 2 over xy. It's equal to 1 over x squared times y cubed. Recall the form of Bernoulli's equation that you had dy dx plus u of xy. U of x is this y. It's equal to v of x and x term attached to y to power n. So you can see this. This is Bernoulli's equation, right? This u of x is this, y is this, equal to v of x is this, then this. So you have this. So first things first, let's get out the value of n. From here, it's obvious that n is equal to what there? 3. All right. That's your first note. N is equal to 3. Our first step, step 1, was to divide the equation through by what there? Y to power n. So divide through by this term here. And I said, instead of saying divide by y to power 3, what do? Multiply by what there? Y to power what there? Minus 3. I said so earlier. All right, so multiply through by y to power minus 3. It is the same thing as saying divide through by y to power 3. So I'll say multiply by y to power minus 3. Multiplying by this is the same thing, I'm stressing this again, as saying divide by what there? Y to power 3. If you're here earlier, I explained that. So multiply through by y to power minus 3. What do you have there? This one first, y to power minus 3 multiplied by dy dx plus y to power minus 3 multiplied by this one here. So multiplied by 2 over xy, yeah, is equal to this one here, y to power minus 3 multiplying 1 over x squared into y to power 3. So I have this. So what do I have here? This one here becomes y to power minus 3 dy dx. Please make sure you're watching. Just watch. I'll give you time to write. Make sure you're watching. I'll give you time to write. This plus, what do I have here? This becomes 2 all over x. I have this. This and this, what do I have there? I have y into minus 3 times, this is minus 3 plus 1. The plus 1 here. Minus 3 plus 1 gives you what there? Minus 2. I have this. Okay. This is now equal to, in solving this becomes y into minus 3 times minus plus, this is y and y. Minus 3 plus 3 gives you what there? 0. That becomes y to power 0. And that gives you what there? 1. 1 times this gives you what there? Itself. So I'm having this as 1 all over x squared. So all of this gives you 1 over x squared. So I'm at this point. What's the next step again? Step, is it step what now? 2 or 3 now? Step 2 was to multiply through this by what there? 1 minus n. So let's get 1 minus n. 1 minus n is simply equal to 1 minus, what's n? What's n? 3. So 1 minus 3 gives you what there? Minus 2. Multiply through by minus 2. What do you have there? Attach it here. I have what there? Minus 2 y to power minus 3 dy dx. Okay. Plus multiply through by minus 2. minus 2 into this 2 over x y to power minus 2 is equal to minus 2 into 1 all over x squared. Multiply by minus 2. What do I have here? This becomes minus 2 y to power minus 3 into dy dx. Okay? Plus minus is minus times 2. Plus minus is minus times 2 is 2. So that becomes minus 2 times 2 gives you what there? Minus 4 all over x. Bring this one back. Y to power minus 2. Please observe. Plus minus is minus. Minus 2 times 2 is minus 4 all over x. Yeah. Then this, yeah, is equal to minus 2 times 1 is minus 2 all over what there? X squared. So you have this. Now, still following the method there, the next step is to make assumptions. What's the first assumption? You say, let z be equal to what there? Y to power 1 minus n. That's equal to y into what's 1 minus n? Look at this. 1 minus n is simply 1 minus 3. And that gives you what there? Minus 2. So I have this as minus 2. So I'm saying that z is equal to y to power minus 2. So I have this. What's next to begin there? Find what there? dz dy. Find dz dy. What is dz dy? How do you solve this? Very simple. Use, of course I'm differentiating. So I'll use general method of differentiation. What's the concept there? Multiply by the power, subtract 1. What's your power here? Minus 2. Multiply by the power y, subtract 1. Minus 2 minus 1, minus 3. Subtract when you have this. Alright? What was the next step there? We'll now use a chain rule differentiation concept. That was the next step there. From chain rule, we said that dz over dx is equal to dz over dy times dy over dx. What that means is that dz over dx is equal to, what's the value for dz dy? This man here, that's minus 2y to power minus 3. This into dy dx. So this dy over dx. This is the expression for dz dx. Look at the next step there. The next step says we should what there? Substitute the value of what? Z and what? dz dx into your previous equation, equation 2, which is this one here. Put the value of z and dz dx into this equation here. What do you observe? See this step here. Look at this. Minus 2y to power minus 3 dy dx. That's the value for what there? dz dx. So in place of this, I'll put what there? dz dx. So dz dx minus 4 over x. So please write that, please. Substitute the value of z and dz dx into, let's call this asterisk. All right. So you can say put z and, and dz dx into equation asterisk. This. All right. So after this, you now come here. All right. Again, observe I have y to power minus 2. Y to power minus 2 is what we call what there? Z. You can see there. So in place of this one here, I'll put z. So this into z, it's equal to, you now have this, minus 2 all over x squared. Alright, so with this, we've now transformed the equation to a first order non-homogeneous ordinary differential equation, right? So it's now, assume z was y. It's now dy dx minus u of x. Assume z was y. Y is equal to v of x, no longer y again. At this point, let's solve this using the method of solving first order ordinary differential, non-homogeneous, ordinary differential equation. I told you last time, there will come a point where that thing you were doing as a topic is now what there is subtopic. Look at it now. I think we were doing as a topic last time is now a subtopic. So this is the main thing and then a subtopic. How do you solve this stuff there? For this, the concept was get what there? An integrating factor. What we said, before you get integrating factor, what do? Get u of x, right? Let me just divide this because I'm trying to conserve space. Where u of x, from this point here, what's the value of u of x? No. From this point, what's the value of u of x? No. Minus 4 over x. I have to include the sign now. U of x is what is attached to z. We said that last time. So that also includes the sign too. So u of x is minus 4. Let me write it this way. Minus 4 over x. Please take notes, please. The sign is also inclusive. And we said that the value of the integrating factor, if, is equal to exponential integral of minus 4 over x with respect to what there? X. Should I still be wasting my time with what this will give you? You should have mastered this thing by now. Know your final answer. Okay, fine. Let me do it. Don't worry. Let me do it. Let me do it. That's equal to, this would give you, take the minus 4 outside integral sign. That becomes what there? Exponential minus 4 integral of what there? 1 over x dx. We've said to integrate this, take your constant term outside integral sign. You have this. All right. So what do I have here? I will have the integrating factor if. It's equal to exponential minus 4. If I integrate this, what do I get there? Ln x. That becomes this ln x, and this is still equal to, remember that I said that the power goes up there. That becomes what? Exponential ln x to power. This goes up as a power. It becomes what there? Minus 4. Exponential ln x raised to power minus 4. And whenever you have this, what's the final answer here? We said from here, the integrating factor will be equal to, whenever you have exponential ln something, it will be equal to what there? That thing there. Right? I proved this in our previous class. In essence, exponential ln this becomes this as your final answer. X to power minus 4 becomes the final answer. I simplified this in the previous class. All right? Go check in that class. All right. So I have this. What's my next step? My next step would be to multiply the equation by the integrating factor. This equation here, let's call this hash. I should have given these numbers instead. Please, sorry. Multiply equation hash. Multiply equation hash by the integrating factor. What do I have there? I'll have this one here, x to power minus 4 multiplying all of this one here. What I have here is dz dx, dz dx. Is it plus or minus? Minus 4 over xz is equal to this one here. Okay, this multiplies the whole equation. So this into minus 2 over x squared. Right, so that's the next step. All right, so multiply everything through by the integrating factor. Please, we'll do something to make it easier for ourselves. We'll do something to make it easier for ourselves. So here's what we're going to do. Look up, please. Here's what we'll do. I'll express this one here in index form. Please, I'll express this in index form to make it easier for ourselves. This becomes this and this. That's x to the power minus 4 into this dz dx, this and this. So I said express it in index form to make it easier for yourself. All right, so let me express this in index form. So just hang on. I'm trying to do it step by step so that I don't get confused. From here, I can get my final answer. But I'm teaching this step by step. From here, the final answer is already clear. But then let me do step by step. So look up. Let's try to express this one here in index form. So please watch this. This becomes x to the power minus 4 into dz dx. This one here in index form becomes minus 4. This is actually 1. This is 4 times 1 over x. And 1 over x in index form is what there? X power what there? Minus 1. Please. Minus 1 z. It's equal to, this is minus 2 out here. Minus 2 x power what there? Minus 2. Please. All right? 1 over x squared gives you x power minus 2. So this in index form is this one here. So I have this. All right. For now, at this point now we can multiply. It's now looking a bit more friendly. So this and this gives you x to the power minus 4 dz dx minus 4 x into, now I can simply add parts. It saves us that time. Two same b's, x and x, and multiply. What do? Add up the parts. So add minus 4 plus minus 1. Minus 4 plus minus 1 gives you what there? Minus 5. All right. Gives you minus 5. It's equal to minus 2. So minus 2x into, simplify this one here. So it becomes minus 4. Multiply this. So it becomes minus 4. X times x I'm multiplying. So add the parts. Minus 4 plus minus 2. That gives you what there? Minus 6. X power minus 6. So we have this. At this juncture, go back to when we did first order non-homogeneous ordinary differential equation. We said the left hand side will become what there? A differential of what and what there? Of the variable and what there? The integrating factor. So this becomes d over dx times, which variable are we considering here? Which variable? Go and check in the previous class or the previous thing. It was dy dx minus something y. It was always y times what there? Integrating factor. But now it's no longer y, it's now what there? Z. So it becomes what there? Z multiplied by the integrating factor, this one here. That's what there? X to the power minus 4. So see why I was saying if I have this. Oh, thank you. This into z, it's equal to, this becomes minus 2 into x. Of course, this is multiplying this. So x times x, same base, add the power. So I'm having minus 4 multiplied by, or minus 4 plus minus 2. Minus 4 plus minus 2 gives you what there? Minus 6. Just simply add the parts. Minus 4 plus minus 2. So I have this. At this point here, go back to our previous class when we dealt with first order non-homogeneous ordinary differential equation. We said this will be expressed as a differential d over dx of the variable there, which is in our previous class, this was y. So it was now y times integrating factor. But in this case, what do you have here? Z. So this into z multiplied by the integrating factor x to the power minus 4. You now see why I said once you get this point, you're almost done. So at this point, just bear in mind that from here is simply d over dx of the variable there, z, times this is equal to, I'll just multiply this by the end result and proceed. Anyways, this is equal to minus 2x to the power minus 6. I have this. All right, let's do this. Let's do this. The next step there was moving this one over here such that I'll be left with d to this. So d of z dot x to the power minus 4, it's equal to this one here, minus 2x to the power minus 6. The x comes this way, becomes what there? The x. This is correct, right? If you want, you can say cross multiply, but this one comes here. It's correct. At this point here, what's next there? Integrating both sides. So integrating both sides. Okay, both sides. What have we got? We have that the integral of d to z dot x to the power minus 4 is equal to the integral of this minus 2x to the power minus 6 dx. Let's proceed. All right, so what have we got? Let's recall what we said in the last class. We said if you have integral and d, what happens there? Integral cancels d, always. So I'm left with what there? Z dot x to the power minus 4, it's equal to, how do you integrate this one here? What do you do? First things first, move the constant term outside integral sign. My constant term here is minus 2, so minus 2, move it outside integral sign, x to the power minus 6 dx. How do you solve this? This now becomes general method of integration, or the power method of what there? Integration. What do? You add 1 to the power and do what there? Divide by the result. Add 1 to the power, divide by result. What do I have there? This becomes z dot x to the power minus 4. It's equal to, I have minus 2. In solving this, I have something that looks like this. This into minus 6. I will add 1 to the power and divide by the result. So you have this. Then plus c. You have this. Right. So in solving this, what do I have here? This is z dot x to the power minus 4. It's equal to, this gives you minus 2x to the power minus 6 plus 1 minus 5 all over minus 6 plus 1 minus 5 plus the constant of integration. From here, obviously, minus cancels minus. I'm left with z being, or z dot x to the power minus 4 being equal to, what do I have here? This is 2 over 5 x to the power, this is 2 over 5. Shift this one out, I have x to the power minus 5 plus c. Your next task again from here, you want to get z. So what do I do here? I want to get z. What do I do here? Divide by what there? X to the power what there? Minus 4. Divide both sides by x to the power minus 4. I've said this whole divide, and it can be a bit bulky. Let's see. Look at this one. Let me show you something. Let me show you something. Let me show you something. Let me tell you something. Let me show you something. Let me show you something. If I say a, let me do it here. If I say a divided by, look at this please, a divided by x to the power minus 4. Let's simplify this. This is same as saying a divided by x to the power minus 4. This and this are the same thing. Now let's solve this. This is the same as me saying a times, right? Or before then, please, sorry, follow me up please. Before then, express this one here as a fraction. Becomes a divided by what there? This becomes 1 all over x power what there? 4. Correct? Okay. In solving this, how do you solve division? What did you do here? A, change it to what there? Times. And do what there? Invert. Becomes x power what there? 4 over 1. So here's the gist. If I say divide by x to the power minus 4, it is same as what there? Multiply by what there? X to the power what there? 4. The same thing. That's the gist. So by saying divide by this, I can still say multiply by x to the power 4. So it becomes x to the power 4 multiplied by z x to the power minus 4. If you're cool with dividing, go ahead, no problems. You have the same answer. Right? It's equal to x to the power 4 multiplying the next term there. 2 over 5. That's 2 over 5 x to the power minus 4. Let me just do it this way. This times everything there plus c. Same thing. Minus 5, please. Thank you. All right. This 2 minus 5. So multiply by all of this. Let's expand this. What do I have here? This gives you z because minus 4. This is z, x times x. Same base. Add the power. If I add the power, it becomes 4 minus 4, which is what there? 0. X to the power 0 gives you what there? 1. 1 times z is what there? Z. Okay? It's equal to what I have here is 2 over 5. Multiply this 2, it becomes x times x, same base. So x, add up the power. 4 times minus 5 is what there? Minus 1. 4 times minus 5 is minus 1. Plus x to the power 4 times c gives you c x to the power 4. So this times I have this point. At this juncture, are we done? Well, if we were dealing with y, we would have been done. But then we're dealing with z. We have to take z back to what there? Y. Please check. Z and y had a relationship. But z is equal to y to the power what again? Check. Minus 2. So minus 2. Let me replace this here. This means that y to the power minus 2 is equal to 2 over 5 x to the power minus, minus 1 plus c x power there 4. Basically, at this juncture, you are done, but we have to simplify, right? So let's simplify. So we are done here basically, but let's simplify. Let's simplify. Let's simplify this as much as we can. As much as we can. Simplify as much as we can. So as you go higher in your studies, just bear in mind that this is not the one where you jump in close to exam and learn. You cannot. All those exam time revision courses will not work here. You know, look at this, what you're doing here. No, I'm telling you now. Because some people don't understand. I remember back when I was teaching back in school, back when I was in undergraduate, when we were in year 1, we used to do crash course, like crash course to physics, crash course to maths. Let's do 2 days. Let's cover maths in 2 days. Here, doesn't work here. At this point, if you're not ready, you're not ready. There's no magic you do. Look at this. This is just one example. Let's simplify this, please. First things first. This man here is actually what there? 1 over y squared is equal to, this one here can be written as 2 over 5 times 1 over x, right? This is this. Times 1 over x. Yeah? Plus c x to the power 4. We have this. Simplifying this, we have 1 over y squared is equal to 2 times 1, 2 all over this and this 5x plus cx to the power 4. And again, you can still stop here, but we will not. We will not. We want to take inverse and take square root to get the value of y. But we cannot do that. Why? This one is a single equation. For us to say, turn them upside down, right? The idea there is that both sides of the equation must be expressed as a single fraction. This one here is a single fraction. This one here is not a single fraction. So express this one here. You can stop here. It's okay if you want to. But let me simplify this. Express this as a single fraction. I'm having 1 over y squared. How do I express this to a single fraction? Simple. Take LCM. This is all over 1. My LCM here is what there? 5x. 5x divides 5x. You have what there? 1. 1 times 2. 2 plus 5x divided by 1 gives you what there? 5x. 5x times this. 5 times c is 5c. X to the power x times x to the power 4 gives you what there? X to the power 5. This is now a single fraction. Numerator, denominator. At this juncture, you can now turn upside down. If I turn it upside down, this one goes upside down. I have y squared all over 0. All over 0. Y squared all over 1. Turn this upside down now. Is equal to what do you have here? 5x all over 2 plus 5cx by what there? 5. We know that this means y squared. Okay? In essence, what we have here is simply y squared is equal to 5x all over 2 plus 5c x to the power 5. So how do you get y? Take square roots. So y is equal to the square root of 5x all over 2 plus 5c x to the power what there? 5. This becomes the final, most simplified version of your answer. So basically, this is how we solve this question. Any questions, please? Okay, let's move on, please.
Get more by joining our Differential Equations channel membership or visit www.joniemanual.com/courses and get the Differential Equations Made Easy course. Both links in video description.